So you've built an AI demo, right? And it feels like actual magic. But then you try to turn it into a real scalable product and you realize it's a completely different ballgame. Well, today we're laying out the exact blueprint for that. We're going to map out the journey from that simple proof of concept all the way to a production-ready AI system.
We've all seen them, and honestly, we've probably all built them. Those incredible AI demos that just blow people's minds. And that's the trap, isn't it? A cool demo passes the vibe check. It looks amazing, but it's often hiding just how brittle it is. It's not ready for real users, it's not ready for weird edge cases, and it's definitely not ready for business demands. That gap between a cool demo and a durable product, well, that's where the real engineering begins.
All right, so here's our plan. First, we're going to dig into that demo to product gap. Then we'll build our architecture piece by piece. We'll add a solid foundation, figure out how to scale it for production, give it some real autonomy, and finally, we'll make sure it can actually learn from its users.
Every great AI application has to start somewhere. And you know what? Almost all of them begin with the most basic, simple architecture you can possibly imagine.
This is what we call level 0. You know the drill. A user sends a query, it zips over to a model API. Could be OpenAI, could be Google, doesn't matter, and a response comes back. It works. It's simple, and it's absolutely perfect for a demo. But here's the thing. That's it. There's no context, no safety checks, no way to optimize it. This is our starting line for sure, but it is definitely not the finish line.
So, the very first step to evolve our little loop is to build a real foundation under it. This really boils down to two key things: making our AI smarter by giving it the right information, and making it safer by protecting everyone involved.
Okay, now check this out. Our simple loop is already starting to look like a real system. See those new boxes? We've got context construction. That's how we give the model the specific knowledge it needs to give a genuinely accurate answer. And then you see the input and output guardrails. Think of these as the bouncers at the club door, our essential safety nets.
Now, the main way we build that context is with a pattern called Retrieval Augmented Generation, or just RAG. Instead of only relying on its old training data, the model can now go and look things up in real time, from your private documents, a database, or even the web. This is absolutely crucial for cutting down on hallucinations and getting answers that are actually grounded in fact.
And those guardrails, let me be clear, they are completely non-negotiable for a production app. The input guardrails act as a filter before a query ever hits the model. They're looking for things like prompt injection attacks or sensitive personal info. Then, the output guardrails check the model's response before it gets to the user, making sure it's safe, non-toxic, and structured the way you need it to be.
Okay, so now our app is smarter and it's safer. Great. But the next big challenge is making it robust. How do we make sure it's reliable, fast, and doesn't cost a fortune when thousands of people start hammering it all at once?
Now let's see how our architecture evolves to handle that scale. If you look inside the Model API block, there's a new piece, routing. See, as your application gets more complex, you're not going to rely on just one model. You'll probably have several for different tasks. And a router is like a smart traffic cop that decides which model is the best and the most cost-effective for any given query.
This router is usually part of a much bigger component called a model gateway. The best way to think of it is as a central control tower for all your AI models. It gives your developers one clean, simple API to use, it can automatically switch to a backup model if one fails, and it gives you one dashboard to track all your costs. It's really the key to taming all that complexity. Another huge part of scaling is managing speed and cost, and that's where caching comes in. The simplest kind is exact caching. If two people ask the exact same question, you just serve up the first answer from memory. Done. But then there's semantic caching. It's way more powerful, but trickier. It can recognize if a new question means the same thing as a previous one and just reuse that old answer. This alone can save you an absolute fortune in API calls.
And this diagram shows you exactly where caching fits in. It sits right at the front of the line. It intercepts every query that comes in, and if it finds a match, boom, it sends a response back instantly without having to do all the heavy lifting. This one simple block can make a dramatic difference in both latency for your users and the size of your API bills.
So far, everything we've built is designed to respond to a single query. But what if we want our AI to handle complex, multi-step tasks all by itself? This is where we make the leap from a simple tool to a truly autonomous agent.
Okay, the critical change here is that new yellow arrow.
That feedback loop is the architectural key that unlocks this agent-like behavior. It allows the output from the model to be fed right back into the system as a new input. It's a simple concept, but this loop is what enables the AI to reason, to plan, and to execute a whole series of actions until a job is actually done.
This is what we mean when we talk about agentic patterns. An agent doesn't just answer a question. It performs tasks. It can use tools like searching the web or querying a database. And most importantly, it can take right actions. It can actually do things in the real world, like send an email, book a flight for you, or update a record in your CRM.
So let's just walk through how that loop works. An agent gets a complex goal. Say, plan a weekend trip to Sydney. It takes a first step. Maybe it searches for flights. Then it evaluates its own work. It asks, am I done? And if the answer is no, it loops back, using what it just found to take the next step, like searching for hotels. It just keeps doing this, looping and refining until the entire task is complete.
All right, we've got a smart, safe, scalable, and autonomous system. But the truly great, category-defining AI products have one more feature. They get better and better the more people use them. This is the data flywheel. A system learns from feedback, and feedback really comes in two main flavors. There's explicit feedback. That's the obvious stuff. The thumbs up button or a star rating. It's high-quality data, but you don't get a lot of it. The real goldmine is implicit feedback. This is what you have to figure out from user behavior. Did they click the link you suggested? Did they immediately rephrase their question? This tells you what they really wanted.
Here's a perfect example of that in action. Imagine you ask an AI to find a hotel. It gives you 3 options. If your very next message is, okay, those are a bit pricey, can you find something under $200 a night? You just gave the system incredibly powerful feedback about your preferences, and you never had to click a dislike button. The best systems are designed specifically to capture these subtle conversational signals.
So if you remember just one thing from this whole explainer, please let it be this. The magic isn't just in the model. Building a truly great AI product is a system engineering problem. It requires careful, deliberate thought about context, safety, scale, autonomy, and feedback. All the pieces we just walked through.
And that really brings us to the final question, the one I want to leave you with. Take a hard look at the AI project you're working on, or maybe the one you're just dreaming of building. After seeing this blueprint, you've got to ask yourself, are you building a product, or are you still just building a demo?